All right. Hello, everybody. Welcome to Data Science Office Hours. We're all very excited to be here with you after a little bit of confusion last week and a break the week before. We have a very exciting topic today that we're talking about, data visualization. It's something that is an important part of being a data scientist. I'm joined here by Andreas, Fabio, Eric, and Sarah. We're missing Terry and Kate tonight, but hopefully they'll be able to join us in our next office hours. And today, or tonight rather, I guess, or this morning, depending on where you are in the world, we're going to talk about data visualization, why it's important, what are some common problems that you may run into, and some tools and methods that we like to use for data visualization. And if you have questions or comments, please comment on YouTube, and we'll do our best to answer those as well. But as usual, we'll probably spend the first part of the office hours kind of with more structured discussion, and then we will turn and answer questions towards the last half. And so to kind of start off, and before I ask others what their perspective about data visualization is, but for me, coming from a biology background, data visualization is one of my favorite parts of data science. Humans are very visual creatures, and it's so much easier to tell a story with data and really understand what your data is saying when you look at a graph or a chart as opposed to looking at a table. I've had so many instances where presentation of the data matters, and a good visualization can make a massive difference in how your analysis is received or the insights that you uncover. In fact, when I was first learning how to read scientific research papers, professor who taught me in my first lab meeting, he kind of, watching him read, he scanned through the title, then he with 30, 40 years of research under his belt, and he was just looking at pictures as the primary way of him doing science. And that taught me something very important about the importance of visualization. So I'm really excited that we're talking about this tonight. And I don't know if anyone else wants to add their kind of 2 cents about why visualization is important or their thoughts about it. So. All right, Fabio.
All right. Hi, and thank you all for being here right now. Kate uploaded a video like half an hour ago, so if you guys can just go and see it, maybe later, maybe after the session, she talks about Tableau and her experience in database, so don't miss that out. So I think for me, I come from physics, and I understand what Boss is saying, because when I started doing just simple plots, and most of the time I did them was to not right now like I do it to understand the data, but to understand the results. At that moment, maybe like 6 years ago, and when I started like seeing all these kind of different plots that people use on papers or presentations, first I was really like overwhelmed. Like uh, they were not really easy, and I think that's something really different from data science right now. I think we can have really weird plots, but I think we can divide this field in 2 parts: the database for you and the database for someone else. And I think they're very different. Right now, I can have my notebook with all kind of visualizations just for me to understand the outliers of the data or some kind of structure they have, and something I will not present to the business because they won't understand what I'm saying. And the other part, I think, is the best part of trying to communicate ideas with your plots. And this is different because you have to think who's your audience, and how to explain really hard concepts that are, and that could take you 2 days to do a study that just ended in an Instagram. So that happens sometimes, and you have to condensate all of this kind of history and work into 2 or 3 plots that will have to signify everything for that kind of presentation. So I think the big difference from presenting results in data science as in science is like, when you're presenting a scientist results, they will expect to be informed on how to read those plots, and they have to know how to understand the structure of the plots. But when you're doing the same thing, presenting the results for your team or for the business you're working to, you need to understand that they are not informed on how to read big, different, and weird plots. So I think for me, the hardest part on creating these great plots is understanding the difference between plots from you and plots from the business, for the business, sorry.
So I'm going to jump in, and I think what I'm going to say is probably an extension of what Fabio started touching on. But in a lot of ways, we talk at length about how difficult it is to communicate in data science, and we say that's like maybe one of the hardest skills to develop. And people often assume that communication has to be in written text, right? Like you assume that, okay, I have to get better at writing emails, I have to get better at authoring reports. But if you become really good at data visualization, you can actually connect with a lot more people with far less words. And I think that's something that's been shown time and time again across all of companies of all shapes and sizes, is that if you are good at visualization, a good visualization will take care of so many words, and it's something that can be really helpful in trying to bridge the gap between people who maybe have less, they have differing levels of technical expertise. And that's particularly true for data scientists who are interacting with non-data scientists on a regular basis. So I'm gonna hang up and listen, as they say on radio.
Yeah, like so all of those have been very good points. I mean, knowing your audience is a huge part of coming up with a good data visualization. So the things that I want to say kind of to work off of Bo's point is that, and something that I noticed, so like within industry, so I'm going to take this two routes, kind of what I've seen happen in my company, where we were sending out massive Excel spreadsheets with every cut of the data that you could possibly want. That took kind of our media buyers like at least a day to put together, and then you send it to the client and it's just a massive dump of everything. And honestly, that allows the client a lot of flexibility to kind of just do whatever they want with the data. But then how do you find that needle in a haystack, right? Like, how do you find that that insight that's going to essentially help you with the millions of dollars that they're spending in advertising, right? So there's like 1 or 2 major points in there that can't be uncovered unless you are smart about the way you kind of put that into a visual that's understood by your audience. The one thing which we'll eventually get to, are the challenges that come with putting that together. But for the importance of data visualization, when I think of all the massive amounts of data that we have that's all fragmented everywhere all over the web, the reason why data visualization is important is to essentially bring that all together and consolidate it somewhere. And like the way we understand things is, like the way our brain comprehends things is visually first. We understand a lot of things through just very simple visualization. So being able to consolidate everything into like essentially what you could call knowledge compression into like one visual that people can understand relative values. Like there was a very good visualization that I saw of like the US spending massive amounts, billions of dollars of data, and billions of dollars. And it's like you see one figure on one article, another figure on another article, and being able to bring that together and see relative values is very important. So, so I'll leave it at that.
Okay. But for me, plots for the business are very important. And so what I have learned over the years is, you guys have talked a bit about this, dialing it to the audience. So it's super important. And it's one thing that I've seen a lot of guys do wrong, is not dial it to the audience, because to an executive, you have to do a totally different presentation as to another data scientist, as to a colleague, and so on. So it's really super important to keep in mind who is getting the presentation and what are his goals, and to keep it very simple, not to go all out, and like Sarah said, always do a huge data dump, and people are basically overwhelmed with the presentation, 100 pages presentation, each slide with two charts and so on. So don't go overboard. And what I have also learned over the years is that everything ends up in PowerPoint. So whatever you do, it always ends up in PowerPoint, because everybody has PowerPoint and everybody is used to PowerPoint, and a lot of guys are expecting PowerPoint. And so that's another funny part. Yeah, just to tease it, because I think we are going to get into this more. Another part is for the data scientists. I think Fabio has already mentioned that. I'm coming from the platform business, and so it's very important to visualize data for the data scientists. And this, yeah, I'm going to get into that later.
All right, thank you, Andreas. I agree very much with what everyone's been saying, and you know, data visualization, as everyone says, can play multiple roles in your data science pipeline. It can be very useful in data exploration, you know, just getting a sense of what your data is like, and that's kind of the audience in that case would be you or other data scientists. It can be incredibly useful while you're modeling, kind of get feedback on how modeling is, and then it also is very often a deliverable or final product or a component of a final product, and that may be as part of a report or a PowerPoint presentation, as Andreas pointed out, but it also may be an interactive dashboard. And we had a question about when are interactive dashboards important, and I think they're incredibly important for a number of reasons. One, I've been in a similar situation like Sarah, where so much of the data team's job was preparing these elaborate Excel reports. And it's just a nightmare. And in one job I got so sick of having to do that I automated a dashboard so I didn't have to do that anymore. And then I could focus more on data science things. So I built out a dashboard so that they could pull all the custom reports that they wanted. And so I didn't have to be involved in the process anymore. And so that was kind of just out of sheer frustration to you know, free up me to do kind of more interesting data science things. But also I just had a case yesterday where I was trying to explore a problem, and I created a very quick, shiny dashboard to visualize my data set and the relationship between variables. And you can have, you know, vary the values of different variables and kind of produce like an ad hoc sensitivity analysis or something like that. And that can be incredibly useful to understanding, you know, while you're trying to work through a problem, you know, having interactive components can be very useful. And yeah, so I just wanted to kind of make that plug for interactivity.
Cool. One thing I wanted to make sure is part of our discussion, I think when people talk about data visualization, they talk about it like there's a shared like everybody sees the same thing when they see a visualization. But that's something that I think we need to be skeptical of and understand that when you are creating a visualization, you may have one way of looking at it. Someone else may see something completely different. They may derive a completely different meaning from a visualization. And it's something that I think is worth discussing, because we deal with so many different audiences on a daily basis that creating data visualization sort of in a vacuum without really trying to consider the ways in which it might be interpreted by various audiences, I think can be a little dangerous. So I think it's part of our discussion is how do you create a visualization that is useful for multiple audiences, given that we often are so close to the data and so familiar with it, that we need to be able to take a step back. That's hard to do when you're working under pressure trying to create a visualization. So I just wanted to set that up as part of our conversation going forward.
All right. I think in a different. I think that's a very good point, Eric, and we all should be aware of that when creating some visualization. But I think one of the like last thing happen with plots for or core in data science is that right now a lot of people are just creating models with maybe Caret from R or scikit-learn from Python or Spark or whatever. And I saw I think it was a slide from a class that says the process of creating a machine learning code was like just downloading a library and just typing 10 lines of code. And someone really clever, I think it was Imad from LinkedIn, replied, it can take you 10 years of experience to write those 10 lines of code, right? And the thing here is, before just thinking that it's just really hard to visualize a model, to explain it to someone else in your team, there are ways now that you can explain machine learning models that are not only black boxes for your team. I think someone there just answer just said like, hey, what should I do if I need to explain a really hard concept from machine learning to someone? And right now there are great libraries like Lime. I don't know if someone else heard of that. And Lime right now is trying to create some simple plots that will allow you to explain the model for yourself and for your team. They're not for the business. You want to explain how PCA or a deep neural network is actually working for the business. But I think the communication between data scientists in a team has to be more than just code in a GitHub repository. I think we can just create some this for ourselves and for our team to explain and have a like internal report that can explain our models. I'm trying really hard right now to extend the functionality of Lime for Spark. And I think it's a really good tool that can allow you to explain visually how the model that you think is a black box model is working. Yeah.
I very much agree with that, Fabio. And Lime is really cool. Cool package. I know that they. There's a port into R as well from the Python library, so you can play with it in Python and in R, and it is really cool. So I think we've done some good definitions of data visualization and kind of the scope out of why it's important, where you might use it. We can start. I wanted to talk a little bit about what are some challenges that you run into. And I'm teaching a data science boot camp right now, as is Sarah, the same program but at a different school. and you know, I kind of came up with a list of cardinal data sins, you know, from my class. I wanted to discuss just a couple of them, and I think kind of the underlying principle is if you look at political journalism and look at the charts that they use, don't do that. So I think that it's really easy to lie with charts and with data. It's really easy to do that. And I think that as a data scientist, you need to always tell the truth with your plot. You know, there may be parts of the truth that need to be uncovered or aren't immediately understandable, but you need to tell the truth. It's ultimately in your best interest and in the business best interest that you're telling the truth of what's actually going on with your data. And so some simple ways that people lie with plots is, one is manipulating axes. So that your axis starts at 300 and goes all the way up to 301, you know, your y-axis, and then you know that all of a sudden makes the effect or difference look huge when in reality, if it was scaled out appropriately, you know, you would say, okay, that's not that big of a difference. So that's one common thing. I think pie charts are just something that need to die. Our brains really have a really hard time telling the difference of size and area. And so I say, you know, pie charts usually are okay if you have maybe 2 categories in your pie or 2 slices of your pie, but anything more than that, you know, consider a bar chart or some other way of showing the differences. You know, those are just, you know, and then one last problem that I had a boss once who was colorblind, and I produced this really beautiful chart, ggplot. It was really awesome, unlike anything that they'd ever seen before. And I showed it to him, and he's like, "Oh, that looks really great. Can you tell me what colors these are?" And he couldn't see the difference. And I learned, like, that was a really important lesson about considering your audience. You know, I went and I found a colorblind palette that went along with our kind of our brand identity, and that made a huge difference to him because he could tell what I was showing him. You know, and that was something that I hadn't encountered before, but it's something really important to consider. So.
Yeah, that's a good point. I get asked sometimes to differentiate colors. So on the topic of kind of some difficulties and challenges that I've kind of seen, first of all, so one point I'll make is that just because you can create all these charts and every single cut of the data doesn't mean that you should, because I've seen PowerPoints, right, of like 126 pages, and I'm like, no one is going to go through that. Like, good for you that you made all those different visuals, but like no one's going, like not every single one of them is useful, right? So back to this data consolidation idea, if you can, instead of making a graph for Facebook, a graph for Instagram, a graph for Snapchat, a graph for all these different platforms, try and like consolidate that all together. Find some common KPIs across all of the platforms or across all the different, you know, things that you're looking at, and try and make it understandable and readable all in. Try and consolidate as much as you can. Another thing that I've seen is kind of to Fabio's point, you know, data visualizations for you and data visualizations for me. So I've seen some very smart people put together some nice, very like interesting interest graphs, and it's just like, and it's so amazing, and obviously we understand it, but then you show it to anyone else and they're gonna be like, I don't get it. Like, what are you trying to tell me here? And then if it requires you to explain a lot, then it's not doing its job, right? So to Eric's point is that it should kind of explain itself. Like it should be able to cover a lot more words than you'd have to explain. So that's another thing that I've seen. And then kind of what we've all been saying over and over is know your audience and know what story you're trying to tell, right? So just by knowing what question you're trying to answer with that visual could really help you in kind of determining what you want to encompass in that. So I'll leave it at that.
Yeah, I think those were really, really good points. And I think that's very true. I've seen some great viz that I kind of get it. And I'm thinking, if I'm kind of getting this, how about the business guy just right next to me? Is he understanding what this guy's saying? So I think that's a very good point. So for me, challenging, I think there's a lot of stuff. And first, I think when I'm teaching a course right now on data science, and when I went into plotting, and I'm using Python for that, and it's not obvious. I think we can go maybe later into tools and stuff, but there were other packages like SAS or Excel that were really easy to use to create plots, or maybe Tableau. And when you say like business people that are taking this course, hey, you need to program 10 lines of code to get a simple bar chart. Like, man, this is not really easy to do. And it's not always really obvious what you're doing with the plot. And when you finish it, you have, and I think the documentation for some packages in Python is not the best. And you have to go to a lot of different Stack Overflow questions, try to see how to move just a simple kind of number, and how to add a simple text here and stuff, something that will be really easy with other tools. And I'm trying to I don't know to inform them that, yeah, this could be easier with other tools, but you have more flexibility with these languages. And I think that is challenging for a lot of people that's trying to change maybe works from business analysts that you are used to work with all of these different kind of big packages for doing everything, to go into just running a notebook and that's it. And I think something that was actually really hard for me in the beginning, is understanding what people really wants to see. And I think it depends on the people you're working with. I think it's not the same for every manager. Yeah, every manager needs to see bar charts, and that's not true. And this goes, I think, a little beyond knowing your audience, because yeah, you can just look in the internet how to impress your boss with a data visualization, but he's not the boss from that question. He's a different kind of person, and not all of us learn the same from the same picture. And I think a good way here, and this is what I did, and I just asked him, hey, how would you like to see this data? How would you like, I mean, how do, and at that time I created some different plots, and hey, do you understand this more than this? And I tried to find a way of, because he was the guy who's gonna see all my plots all the time, so he needs to understand them. So what I did there is I really knew my audience, and this deep connection that a person can have to a graph. And yeah, if you always do this graph for me, I will always understand what you're saying. Of course, that's not possible for every kind of data set, but there's a lot of things and plots to play with, and libraries and tools. So I think the best way to get started with this is, yes, do your research about who's your audience and stuff, but go a little further and ask them. I mean, they won't get mad if you show them not one but three, and just in the end, hey, which one was best for you? And then you start understanding what they like to see from that moment.
So something that's come out of these previous conversations is, I think it's also important to consider when is a visualization necessary, right? So I think, and this is specifically for, I think about business decision makers, because so think of a couple examples. Let's say on one hand, you have the option of sending them a report that shows up daily, and it just gives current readouts of metrics, right? It just has literally a list of 4 key metrics, and that's all that they need. Maybe a visualization isn't necessary in that case. An example would be, let's say that you create a dashboard and it's a time series of these metrics over the past month. And humans are pattern finding machines. We find patterns in things whether or not they are there. And so when you show something like a trend over time, no matter what, we can't help but try and assume that there's causality or there's something happening, even if we see little ups and downs in the data. So I think it's really important to consider why, in what case it might be more dangerous to create a dashboard, because let's say that you have 2 days where a metric goes down, right? And maybe, and all that, and it may just be noise, but in this case, maybe they make a key decision off of it, even though it was just noise. And perhaps the visualization in that case actually ended up hurting the business more than helping it. I think it's important to consider, like, before you try to visualize something and before you share it with people, think about the ways in which they might interpret it and might make the wrong decision. Because you want, part of your job is also steering them in the right direction with whatever visualization you create.
I'd like to pivot away quickly from creating data, creating visualizations for other people, to a problem that I'm facing a lot, is create visualizations actually for the data scientists for the daily work on a platform. Because when you look at the usual process of, for instance, machine learning, is you get some data, you set the hyperparameters, you train the models, you test, and then you do it all over again, and so on. Sorry, and that works fine when on your laptop or whatever, when you're doing research or when you're doing a proof of concept. But when the problem I'm facing is now you have a lot of data scientists or multiple data scientists, and you have a lot of data, and you have a lot of applications and a lot of models, and so the models need to get trained automatically and analyzed automatically how good they fit and so on, and somehow you need to display this to the data scientists, because you cannot look at all the outcomes, or easily, and you cannot do it on your laptop, and you can't use standard tools. And then there's the topic of dashboards coming in again, like Bo said a few minutes ago. And so you need to somehow create dashboards that that you can fill with actual the data from the models, from the creation, from the automation, to actually give the data scientists a indication what is actually happening, how good is everything working, and in what part or what parts of data can he use, or should he look at. Because when you also think about how much data is getting created and getting processed, you cannot look at all the data anymore, because it's too big for the RAM of your laptop or of your PC, and then it gets really complicated, and you have to automate getting statistics out of the data. So the data scientists can limit the visualization, and it's something. I'm looking a lot at custom dashboards online, and it's a huge issue I'm currently working on, and I'm not really sure. I think maybe Eric can relate to that most, as he's at LinkedIn, another big company, and it's I don't have a 100% solution. I'm also learning as I go, and maybe there are some platform providers who already provide something like this. Maybe if you're one of them, get in touch with me. Yeah. I hope this wasn't too complicated or too confusing.
All right. So I think we can take a moment now, each of us, to talk about the tools we actually use for doing this kind of plots and visualization. So I changed from R to Python like 3 years ago, and I really loved R before. Like ggplot and all of those kind of things were really awesome, and I still miss them. And but I'm gonna mainly talk about some Python tools right now because I'm using them. So I think the first tool everyone should at least be aware that exists is Matplotlib. And Matplotlib is not super easy to work with, and sometimes it's really weird, but it's really powerful. I think you can create a lot of good types of plots and just ready for maybe your team or for a business presentation. And the community is really good. I mean, if you have a question, I can assure that someone else had it before, and there's an answer in Stack Overflow. So you're not lost with a tool that no one uses. Other tool that I've been using a lot this year and last year was Bokeh. And Bokeh is a really good library for plotting in Python. I think it's similar in a lot of ways to Matplotlib, but the thing here is it's really easy to make interactive plots. And some things I was missing when working with in Python was this interactivity I had from all the tools from like Shiny and stuff from R. So with Bokeh, you can create dashboards right now, and it's not super hard to do, and it's an interesting plugin library. Right now, I've been using two, like they're not famous, but they're really cool. One is called Shader. This tool is really cool for plotting a lot of data. This was actually one of my challenges. What if I need to plot a lot of data? Sometimes this is not a good idea. Sometimes you have to just restrict your data and plot it. Well, what if you really need to plot big data? And this is one of those libraries. And they have really cool examples over there. And it is being used right now a lot for plotting. I will write the names of the packages right now after my short speech here. And the last one is Vix, and this is really similar to Data Shader, and it's really cool for actually plotting maps too. So I think if you really want to plot maps on Python that looks really, really awesome, these two libraries here that I just mentioned are really funny. And last thing I want to say, if you come from R and you really love the HTML, the HTML widgets that you have there, now there are like Jupyter widgets and HTML widgets for Python right now. And you have and you can connect all of these kind of different libraries, like Bokeh and Data Shader and HTML widgets for Python to create a really good looking dashboard in Python too. So I think Python is finally catching up with R in database tools. They're not super easy to use. Some of them are missing the great grammar of graphics from ggplot. But I think you can go from zero to do something really interesting in maybe 1 month for each library. So I'll write the names there.
Great. Thank you, Fabio. Those are some really good options for Python. I love, and I'll talk mainly about data visualization in R. So two areas that I feel, so I use R and Python, but I still feel that R exceeds any other language, at least for smaller data sets. I'm not talking about Spark because Optimus is going to fill this need. Fabio's working on, but R makes it, especially tools by RStudio, makes it incredibly easy to do data wrangling, data cleaning, but also data visualization. If you haven't had a chance, you can play around with all of the possibilities that you have with R, not just with ggplots, but using R Markdown or Knitter or Shiny. I've used R to automate PDF reports that are I've set on a cron job and just automatically put out and formatted and then emailed to to the person that's consuming the report. You can build out presentations directly within R. You can create HTML web pages. A couple of years ago, I created a bot for my wife that posted her favorite deals or the best deals from her favorite sites on her blog, and I did that all within R. So I just published a WordPress post automatically from R a couple times a day that had and so there's really a ton of kind of visualization options within R. ggplot is great, and if you do anything in R, you definitely need to get away from base R graphics, and you need to learn ggplot. Plotly is a library that can be really great and is not only accessible from R but also from Python and JavaScript, and it's a very great library to learn. I love Shiny just because I've coded dashboards by hand front end, in Bootstrap and D3 and JavaScript, and you can do some really cool, really powerful things, and all the cool visualizations that you see from like 538 or New York Times, those are all done in D3, but it's a pain to code those things from scratch. Shiny makes that really easy. I don't know, if you spend a little bit of time to learn the syntax, it's incredibly easy to throw up a dashboard quickly, and so those are some great tools available to you in the R universe.
I think you covered all the ones I was going to talk about, but so I think what we'll realize as we go through this is we're probably using a lot of the same libraries, just because they're all going to kind of like Matplotlib and ggplot are going to be the main ones. You're going to use ggplot in R and Matplotlib in Python. In terms of when I think about data visualization and which libraries or tools I would be using, it would just depend on the circumstance, right? So if I need to present data, if I just want a quick understanding of my data, probably throwing it in Tableau would be the easiest way, instead of like a bar chart. Like, could be really simple in Tableau versus in Matplotlib. So if I just want a quick understanding, okay, just throw it in there, kind of get a sense of what kind of data I'm working with, and then probably transfer it over into a more customized plot that I can work out, like it just basically customize it a lot more in Python. When I think of interactivity, so Bo mentioned Plotly. Plotly is great because it can work across languages. And then in Python especially, I like working with Seaborn just because it's good for statistical plots, and it just comes out really nice, and it works right off of Matplotlib. So that one's really nice. And I think one that we haven't mentioned for like geomapping is Leaflet, and Leaflet's pretty good. And I think we just finished covering that in my class, so I thought I'd mention that. And yeah, so I'll end there.
Yeah,
I have
sorry.
Oh, sorry. I like how I started my statement. I have nothing super meaningful to add, which is a good way to start a statement to get people to listen. But I think something important to bring up is not to undersell the usefulness of Tableau. We at LinkedIn, we are heavy users of it. A lot of our business partners are very accustomed to the types of visuals it can provide. And it's something that, while it might not show up in a lot of data science discussions because it is maybe less customizable, the learning curve for it is so much less that it's very popular. And it's something that if you're looking to be in data science and get if you look at job ads, right? So many of them are going to mention Tableau. I guarantee that's going to happen. And it's just something to have in your skill set. It's worth doing some basic training in it to have familiarity with it. And my computer right now, I have a Tableau dashboard open up on the back, and I'm currently regretting that I don't know a lot more about it. So just a thought.
Yeah, what I was saying is, like for online dashboards, it's very powerful with Bootstrap and D3.js. So it's very, those are very simple libraries and or tools that you can use to create online dashboards. And I've seen some very cool dashboards just with those. So it makes sense to look at D3.js.
All right, but I think you were interested now on talking how visualization hoarded or contributed to a process in data science, right?
Yeah, I thought that maybe if any of us, we only have a couple minutes left, but if we had any stories of where it's been, particularly useful at a point in our career or some, project that we've been a part of, I thought that could be really interesting. So I could start really briefly if you'd like, unless Fabio, you have something to share. So, I worked for a company where part of what we did was develop new methodologies, new analytical methods, and we had this feature selection method that we'd come up with, and we were using it in the context of genomics to help identify which SNPs or single nucleotide polymorphisms were most important on the genome. So basically, what parts of a gene is most different between two populations. Traditionally, people use t-tests to do that, or some other kind of standard method like that. And we were comparing kind of what the researchers standardly used against our method. And so I was tasked as finding out what the story was. I produced some plots, and I found that the SNPs that we identified and the SNPs that the researchers identified, there were only two that overlapped of about 1 million SNPs. And I ran some probability analysis and found that it was incredibly unlikely that we would have such low overlap. And so initially we kind of panicked because, like, okay, this either means our method is really bad or their method is really bad. And because they're using the standard method in the field, this doesn't look good for our method. And so luckily dug a little bit deeper to actually looking at the distributions of what we had picked versus what they had picked. I used some box plots, histograms. I really like, for audiences that aren't familiar with box plots or histograms, I like using a smoothed histogram. And it became very clear once we did that, some deeper digging into what the actual distributions of the data was, that we were picking the correct differences, and that the traditional t-tests were actually finding SNPs where their means may have been different, but if you looked at the overlap of the distribution of the data, it was actually a lot fuzzier and a lot messier. And so that was really cool, because we could start the presentation saying, "Oh no, our method doesn't work," and then never mind, if you look at what actually is going on, it's a lot better. So that was one case where data visualization was absolutely critical in telling the right story about what was going on.
I prefaced this story a little bit before. I'm going to say a previous employer, more like on a consulting side. But when you're taking data visualizations to like an executive or to a boardroom, they are always going to be looking for trends in the data, right? They want to find trends. And I mentioned that people want to see patterns. And I remember creating a visualization of this metric over time. My intention when I created it was essentially to show that no, it's not changing at all. Like, it's not varying much over the past 24 months. And I remember the first comment from one of the executives was, well, I can tell it goes up in August and September, and it goes down here, and then it goes up here. And so they were reading so much into it that the point that I intended to illustrate, that there wasn't anything changing, was completely overridden. And I think it can be it's a very tough lesson when you're starting in a data position, and then the story you want to tell is not the story that ends up being communicated to other people. And it's very important to consider, this is just a recommendation, before you go in and do a presentation, talk to other people, not the data scientists sitting around you, but other people in the business, and say, if I show this to you, like, what do you think? Does it make sense? What do you see? I think that question of what do you see is a pretty powerful one for understanding if your visualization is doing the thing that you want it to do.
One good use case I had for a data visualization a few years back has nothing to do with data science, but with visualization. We had the discussion a lot, why do we need big data? What is big data? And why do we need the tools and so on? And I just made one slide with a chart. And then I said, okay, look, this is about 1,000 pixels. And now imagine for one machine, you have 100,000 screens. And then that's how much data there is. And so this is why you need the tools, because you cannot look at the data anymore. And that was quite effective, I'd say.
I don't have much to add here. I can think of at least once where I've kind of had to be in charge of looking at, I was approached by a client saying, hey, this is the question we want to answer. And, after looking at the data and kind of experimenting with kind of what we had available, coming up with some, general box plots and trying to do an analysis as to kind of what they were looking for. And sometimes you'll realize you don't even have the right data or the right visual to kind of answer that question. And then you have to approach it from a totally different way. And you have to say, okay, well, how can we set up an experiment and run a statistical test on, basically, to help answer your question. So, I mean, we end up doing a lot of visualizations, and everything that comes out of our analytics team and our data science team ends up influencing strategy anyways. So all of it has to some extent some impact. But in terms of coming up with one particular moment in time, I don't have one on the top of my head, but I think yeah. So every visual that we've ever put together has kind of been a part of some bigger story that is going to influence kind of how we spend millions of dollars across different platforms. So
yeah, I think I would like to answer some questions from people right now, because we have 5 minutes. So there's a lot of questions out there. They're not really easy to find. But if some of you guys have something that you really want to answer right now, okay, I see someone about how to visualize neural net and stuff. And I think it's not a net, but TensorBoard is really cool, and to just try to show your nets. And I think when it comes to models, I think you really need to be clever on how are you going to talk to the business about what are your findings. It's not the same to tell someone, yeah, I found out that people are accessing our website from 7 p.m. to 10 p.m. and you present a bar chart. I think that's really straightforward to understand. Then trying to understand really tricky models, and I think the best way to explain a model for a business is don't explain a model to a business. Just don't. They don't need that. They need results, and you can find ways of actually creating some really insights from that, some real insights from those models. And you don't need to explain how are working or the efficiency of the model, of the recall, or whatever thing you're maybe thinking that it will be really awesome to talk about. Just don't do that. They will get really confused when you start saying the word model. That's it. And just try to get insights from your models, even though they're like a simple regression or maybe just a deep neural net. Just try to find insights that people can understand.
Thank you, Fabio. I think that was good. So we had a great discussion today. There are also some really good comments on LinkedIn, covered kind of the whole range of data visualization. Hopefully you found it useful. It was really interesting to me to hear kind of the other tools, the similarities and differences between what all you guys use and what I use. And I love data visualization. It's a part of data science that I'm really glad is a part of data science. It keeps things interesting, and it can be an incredibly useful tool. Something definitely worth spending time learning and learning how to do well. So look at the comments. You know, we listed out some of the libraries and stuff that we talked about, but you know, we will look forward to talking to you again in 2 weeks. I don't know if anyone else has anything they want to say in closing, but no. All right, we'll call it a night then. Thank you all, and we'll see you later.
Thank you.
Bye-bye.
Bye,
See you
everyone.
soon. Bye-bye.